Hey y'all, Miss Kennedy here from Algebra Student, and I'm talking to you. If you are somebody who says, I just need to pass algebra, I'm not going into a math field, I'm not going into a science field, I am going to do fill in the blank, and it's not going to require a whole bunch of math in college or anything like that. I just need to pass algebra. Then this is for you. Like you're my person. Like you're the kind of person that I love to help with math because I understand that sort of mindset. And I'm not like a lot of math teachers who want to convert you into this like math nerd who just loves doing factoring and just, all that kind of stuff. Even though I am a math nerd and I do like to factor because I'm weird like that, but everybody's got their own little things that they're weird about. So, right, like that's my thing. But that doesn't mean I want it to be your thing. Okay. So I just want to make it make sense to you because I know that you want to pass algebra and move on with your life, right? So I'm talking to you. Okay. So I want to show you a sort of a different way that's not usually not taught a whole lot as far as how to figure out factors. If you notice these four problems, they don't have numbers in them other than the little exponents, but they don't have like bigger numbers. So we're not looking at that kind of factor. We're looking at the factor of just the variables, like figuring out the greatest common factor for all those J's and K's and H's or M's and N's and P's or whatever. So here's what I'm going to do. I want us to take a look at like the first little part and then the second and then the last. And we're going to write them down here, and JK means J times K. Like that's all that means, right? Okay. And then negative J squared K or minus J squared K. That is J times K because J squared is just J times J. That's all that means. Okay. And then J squared H is J times H. Okay. All right. So now what you're thinking is, okay, what do they all have in common? Like what can all three of them say? Yeah, I have a J in me, right? Like we can circle a J. So out of all of those, they have at least one J in common, but then the first one doesn't have any more that I haven't circled. So that's it. There's just one J that they have in common. And there's a K here and a K here, but there's not a K in the other one. And there's an H in this last one, but there's not an H in the others. That means that J is the greatest common factor of this term. One J, just that's it. And so if you have to factor it out, because the directions do say factor it out of the expression, then what you do is you take the expression, I'll just write it again over here so that we can see it, and that's plus J squared H. Let me make sure I wrote it right. JK minus J squared K plus J squared H. Okay. And I'm going to put divide by J because factoring is a fancy word for dividing in a sense. It's like dividing. Okay. I didn't mean to put a dot there. Okay. So those J's cancel each other out. You had one on top and you took one away. So they're gone. And so think about what you're left with. All you're left with is a K there. Here you have, I'm going to bring down the minus sign. You have two J's on top and one on the bottom. So if you have two and you take one away, you have one of them left. So you have a J left, and then we didn't do anything with that K. And then I'll bring down the plus sign. And then again, two J's on top, we take one away. So that leaves us with a J, and then we have an H. Okay. And so that's what's left. You just put your GCF, your greatest common factor, in front with parentheses, and you're done. That's a little unique way of doing it. But for some of you, at first, that's going to be the way that's easiest for you. Just to see, oh, okay, this is what's in common to all of them. And so this is what's working here. All right, let's take a look at this next one. So a to the fourth, 1, 2, 3, 4, and then b squared is bb. Okay, so 4 a's multiplied together, that's a to the fourth, and 2 b's multiplied together, that's b squared. And then this one is a to the fourth again, 1, 2, 3, 4, b, c. Okay, so just a b and a c, and then a to the fourth. So 1, 2, 3, 4. All right. it might stand out to you that we said a to the fourth every single time. So think about it. There's an A in common, there's an A in common, and there's an A in common. So there's 4 of them. So we have A to the fourth, because there's four A's that are being multiplied together. There's B's in the first 2, but there's nothing here in the last one. There's not a B in common for that last one. There's not a C in common to all of them. The only thing that's in all 3 rows for all 3 parts is the A's, or are the A's. Which one would you say? Anyway, and so there's 4 of them, so A to the fourth. So the GCF is A to the fourth. And so you're going to divide by A to the fourth throughout the whole thing. And, these A to the fourth cancel. So think, you're taking out A to the fourth. That leaves you with B squared here. Plus, these A to the fourth cancel. It leaves you with B and C multiplied together. So BC plus, because there's a plus there. And if these cancel, it leaves you with nothing, but it's really not nothing. It just means that you're left with 1. So, I don't know if you remember from elementary school, but when you canceled stuff out, it actually meant that it was leaving 1 there. And that's I didn't want it to make a 0. There we go. So, if you don't remember that, just go with it. And if you are really troubled by the fact that A to the fourth divided by A to the fourth is 1, then, leave me a comment and I'll make a video and explain it to you better. But for now, just know if you cancel them both out, it leaves you with 1. Okay, so let's do the process one more time. Let's change colors just for funsies. Okay, so m to the third. So I'm going to write m times m, and then a p, and then an n. And then m squared is going to be 2 of them, 2 of the m's, and then a p, and then n to the third. So n, n, n. Okay, and then an m, and then it's p to the 6th. So p, 1, 2, 3, 4, 5, 6. And you're looking for what you have in common. So there's an m in all 3 rows. There's m's here, but not on the bottom, so I can't combine that. There's a p in all 3. The rest of them don't have the letter P in them, and these have N's up here, but there's not any N's in the bottom. So my GCF is that I have an M and a P. That's my GCF right there, MP. That's it. There's 1 M and 1 P that they have in common, so MP is the GCF. So I'm going to divide everything by MP. And then set it up right. You've got your MP out front, in front of the parentheses, and then you've got your parentheses. So if I have 3 M's on top and I take 1 away, that leaves me with 2. So M squared. The P's cancel, leaves you just with a 1 that's understood. And then you have an N. And then there's a plus. And I have 2 M's on top and I take 1 away. So that leaves me with 1 M. And then a P and a P. And those both cancel out. And that leaves me with N cubed. And then a plus. And I ran out of room. So let me erase my parentheses here. All right. And then here the M's canceled and I have 6 P's on top and I take away 1. So that leaves me with 5. So P to the 5th. All right. So that is my factored expression right there. Okay. Last one. I have a Z and I have an X squared. So Z times X. And then I have a Z and a Y squared. So Z, Y, Y. And I have a Z and a Y. I don't know why I keep saying a Z, but I do. All right. So there they are. There's Z's in every row. There's X's here, but there's no no X's in the others. And there's Y's on the bottom, but there's no X's on top. So nothing else in common. So the only thing they have in common is 1 Z. That's the GCF here. So let's take out a Z from all of these. So that would leave nothing except the X squared plus Take z from this. Those cancel. That leaves me with a y squared. And then there's a minus. And when I take that z out, it leaves me with a y. So there's the factored expression there. Now, if you do this process, a few times, like you probably, if you just watch this video, you probably already have a sense of like, okay, I think, I'm getting the idea that, they have to all be in common. And so, eventually you're just going to be able to look at it in the format that you see here, and you're not necessarily going to have to write it vertically. So don't think, I don't want to do that process because that takes so long. Oh my goodness. Okay, well, I'm going to be real with you. Students that struggle, lots of times that's their attitude. And once they get over that aspect of it, they're like, oh, they realize that what takes so long is actually going to take about a few seconds, and you got to do the math anyway. So it's not like those few seconds could be spent on something else, right? You got to get through this. So if you do those few seconds, then after a few examples or a few practices, you probably don't have to do it that way anymore, because your brain's going to go, oh, that just means every time I see this, this is what I do. And so I just want to encourage you, if you're like, I don't need that math except to get out of high school, right? Well, that's a big hoop. I mean, really, you do have to get through it though. Like you got to go through the math and finish it. And so don't be afraid of doing some little process that helps you think through it, because if it helps you think through it, then it gets you through it faster in the long run. So don't just think about these next 30 seconds. Think about the next month or the next 3 months, and think, okay, I want to be done and I don't want to be back in this class again, right? So, all right, hope that helps. Have a great day.